How many ways can we arrange these four colored balls? Obviously, here is one, right? Arrange it this way. Can we arrange it differently? Of course. I could arrange it something like this. Blue, I need blue. Okay, can we do it any other way? Sure. Can we do it any other way? Yes. Here. But you know what I'm going to ask? How many ways are there? Whoa, how can you keep track of all this, right? Did I repeat anything? I didn't, because I have yellow balls here, so these two cannot be the same. This could have been the same, but I cleverly switched the position of red and they're different. That's what I'm saying. And if I do this, it's going to be different. So you get the feeling, maybe there are infinitely many. It's just, having nothing better to do with life and, having no life, sitting in the half basement somewhere and do this, and you can probably come up with infinitely many you feel deep inside. You don't want to say that, but, you're thinking that. But really, are there infinitely many, or there are just finite? If so, how many? And also, it's just kind of, in the beginning was kind of pretty and colored and all that, but kind of got tiring soon. So how do we do this without actually doing all of that? And imagine that. This was 4 balls. What if it was 27 balls? Ugh. Just seeing that you didn't repeat the same thing twice would take a while. So how do we do this? I will tell you. We have 4 things, right? 4 balls. And when you fill the first ball, the question is how many choices we have. So when we fill the first one, we got 4 choices. When you pick the second one, how many choices? 3. When you have filled the third one, you got 2 left. And last one, you didn't have any choice. So the answer is 24. There are 24 ways to arrange these balls. The thing is, it didn't have to be balls. It could have been numbers. For example, I could have told you these are digits now. Let me use A, B, C, D. How many ways can you arrange these letters? Oh, you're looking at one, right? Now you could have B, A, C, D, and same 9 mirror stars again. How many of them are there? So you just pick 4 places and say, when I fill the first one, how many space do I have? You say, 4, and there are 3, and 2, 1. So this is 24 ways of doing it. Okay, now let's get slightly trickier, shall we? What if they gave you 5 letters? And then ask you to pick, we will not use 4-letter words. We are not that type. So we'll use 3-letter words. Not that they're much better, but they are not 4 letters. So how many ways can we have 3-letter words out of these 5? Well, just start counting. When you choose the first one, how many choices? 5. When you choose the second one, 4 choices. When you pick the third one, 3 choices. So it's 60 ways of doing it, just with the 5 numbers. Now 5 letters. Interesting, huh? What if I gave you A, B, C, D, E, F, 6 letters, and let's pick, shall we get into 4-letter words? No, never. We are not that type. We'll have 5-letter words, okay? So how many 5-letter words can we pick? So let's do it. When we pick the first one, you have 6 choices. When you pick the second one, you got 5, 4, 3, 2. So that would be, whoa, do I have to do this? 30. And this is 12. 30 and 12 will be 360, is 720. Is the answer. This is called permutation. How many ways can you arrange things? And permutation is used when the swapping the order makes different permutation. That is, I'm saying, defining permutation with the permutation. When you have what is seemingly identical, if you just swap just 2 of them, would they still be identical? Let me show you a case here. Do I have one like that? Let me make it. So if I just put it here. Okay, the only difference, let me show you what I mean. The first row and the second row, they got the same thing, namely one color each. In fact, every row has the same thing. But in the first row and second row, you see, the only thing I ever did was swapping these two. Is it different? I mean, same four balls. Well, it depends is the question. In permutation, they are considered different. Well, what do you mean they are considered different? They are different or not? Well, there are cases when they are different and there are cases when they are not. Let me tell you. If I have 4 and 6 and 8. Now, if you made $468 versus when you made $864, are they same or not? Of course not. This is a whole lot better. So if it's different, then it's permutation. Okay? When they are the same, for example, you had a red ball, blue ball, and green ball, then you have red ball. I mean, if you got yellow ball, and if you got four of these balls in your pocket, you could have those four this way, you could have those four this way. It doesn't make any difference. But in this problem that I just gave you, it made a difference because I was asking you to arrange them, not to put them in your pocket. So I was forcing the problem to be permutation. So always ask yourself, would it be different if I swap the location? Then we're dealing with permutation. And when you're dealing with permutation, all the things that I was telling you, how many choices times how many choices, how many left, and multiplying all those numbers, like I showed you before, like this, is how you compute the number of possible permutations.